everybody. This is group 25, introducing slope deflection method, and we're going to do problem 1116 out of the book. This is a frame with 3 supports at A, B, and C, with a cantilever at the end. And now, all we have to do for this problem is find the moment at each end of both of these beams, and we're going to use the matrix method for this today. Now with this matrix method, we're going to look at our boundary conditions for the first beam. And for the first beam, we're not going to have, since it's fixed in, there will be no deflection or slope at A, no deflection at B, but we do have slope at B. And with that, using the matrix, there's delta A is going to go to 0, beta A is going to go to 0, delta B is going to go to 0. So all we have is delta B, so we can take out these first 2 rows. And all we have to do is find the moment for AB and the moment for BA with fixed end supports because there's loading between A and B.
Frame into different pieces, and right here we have the section from A to B with a loading in the middle. And the fixed end moments from the back of the book are here. And they're opposite the sign convention that we use, so when we put them into the equation, we're going to put them in as negative. So based on the matrix that we had before, we get MAB equals negative 2 theta B EI over 6, and based on the fixed end moments, we get, we subtract 4 times 6 over 8, this is PL over 8. And then for the moment BA, we get 4 theta B EI over 6 from the matrix, and we get negative 4 times 6 over 8 from the fixed end moment. Okay, next we have the section from B to D. And if you remember, B is the fixed end, but D is a free end. Based on that, we know that the moment at D is equal to 0 because there can't be any reaction force in the moments at a free end. And we just do simple statics for this part, and we sum the moments at B. And based on that, we get that the moment at BD is equal to negative 9 kilonewtons times meters.
Now we'll be looking at beam B to C with support condition of a fixed end at C and a fixed end at B, but there's going to be allowed rotation at B. So we're going to have the boundary conditions of no deflection at B. We have a slope at B, no deflection at C, and no slope at C. So, with the matrix, it goes to 0. We do have deflection at B. Deflection at C goes to 0. And slope at C goes to 0. So it's going to take out this row, and the first row. Now we can find our moments from there.
Okay, next we're going to look at the beam from B to C. And both of these ends are fixed, and there's no forces acting on it. So we're only going to need the equations from the matrix. And if you remember, we get MBC equals negative 4 theta B EI over 6, and we get MCB equals 2 theta B EI over 6 from the matrix.
The only unknown we have right now is theta B. So to solve theta B, we have to take the sum of moment at B. Remember, for doing that, we take the opposite moment of what we got resolved to solve this part of the equation of the beam. For that, we use simple static. We have that counterclockwise is positive, and we can see out of here which one are positive, negative, solve it, and we have that theta B is minus 9 over EI. After we find out theta B, we plug it back to the equation we're looking for. We solve for it, and depending on the sign they have and where they're standing on the beam, you get to know what direction actually is. Example is for MAB is negative, is standing here. So because it's negative, it goes the other way around. You do that for all 4 of them. And after that, you're done and you're a happy person. Yeah, good.